Good morning, everybody. I'm Enda van der Linde. I am here to explain to you about fractions, proper fractions, improper fractions. But before we start, let's just look at some prior knowledge that you need to have. If you look at the slide that currently before you, you will see there are 2, 4, 6, 8, 10 different circles. The first circle is a 1. It means it is a one whole. And then it has been divided into smaller parts. Important here, you will look at the different parts of, for example, the fifths and the halves. They are divided into equal parts. So a fraction is, we get a fraction when a one whole is divided into smaller equal parts. That is very important that you know that they must be equal. Otherwise, there will be fights over who gets the bigger piece and who gets the smaller piece. Am I right about that? I hope you love maths the way I do, and I hope that you will learn from all these presentations that we make and that we assist you in making the knowledge of mathematics a little bit more understandable. The next slide that I want to show you is fractions. I hope you all know this and you remember. We talk about the top number and the bottom number, but that is only in the class. It actually has a name. The top one we call the numerator, and the bottom one we call the denominator. I'm not going to go into that any further because I think that is prior knowledge. It's just to remind you. When we have to simplify fractions, we have to know what prime numbers are, and we have to know how to calculate the HCF, and you will see there that I've made HCF/GCF. It's the same thing. Some people say it's the highest common factor, other people say it's the greatest common factor, but highest and greatest is for the same thing. Now, first, a few questions about prime numbers. What are prime numbers? Yes, you will see there in the blue, it's numbers with only two factors. I have, in my experience, had learners who confuse even numbers and uneven numbers and prime numbers. They are not the same. A prime number can be an uneven number. Who can tell me what is the smallest even prime number? Good. I'm sure you know that one because everybody asks. The smallest even prime number is 2. Can we have any other even prime numbers? If you look, for example, what I'm going to write there, if you have 14, can 14 be a prime number? No, it cannot be because the factors of 14 is 1 and 2 and 7. 2 times 7 is 14. So as you can see, there are 3 factors, so 14 cannot be a prime number because it has 3 factors. A next question that I want to ask you, can 111, is 111 a prime number? This is my question to you. Now I will give you some time to think about that one. 111, it looks like a prime number, but is it one? How will we determine if 111 is a prime number? We can find the factors of 111. For that, we must know the rules of divisibility. We must know which numbers can be divided into 111 in order for us to see, does it have 2 or 3 or more factors? Now let's see. Is it an even number or uneven? It's uneven. So can it be divided by 2? No, because it is an uneven number. Can it be divided by 3? How do we know when a number can be divided by 3? We add the digits of the number. If I say 1 plus 1 plus 1, I will get 3. If the sum of the digits of the number is divisible by 3 or is a multiple of 3, then that number can be divided by 3. So let's see if we divide 111 by 3. What other factor do we get? We have 3 and divide it into 111. 3 goes into 1. It does not. It cannot. 3 goes into 11 3 times. Remainder 2. So can 21 be divided by 3? Yes, it can. So the factors of 111 will be 1 times 3 times 37. So 111 is not a prime number. Another question for you. Is 91 a prime number? I'll give you some time to think. Maybe you think of it's uneven. Maybe it is a prime number. Now I must look at different prime numbers and see. Can it be divided by 2? No, it is uneven. Can it be divided by 3? If I add 9 plus 1, I get 10, and 10 is not a multiple of 3. So it cannot be divided by 3. 4 is not a prime number. 5, no, it cannot be divided by 5 because the units digit is not a 5 or a 0. 6 is not a prime number. 7, let's see, maybe it can be divided by 7. So I have 91, I'm dividing by 7. Can 7 be divided into 9? Yes, once. It goes in there one time. And remainder 2. Can 7 be divided into 21? Yes. So my answer is 13. So the prime numbers of 91, the factors of 91 will be 1 times 7 times 13, which means that 91 is not a prime number. I hope I've made this clear that you must not confuse prime numbers with uneven numbers. First, find the factors before you decide, is this number a prime number or not? Let's go back to the slides. I'm also having there, what is the biggest 2-digit prime number? 2 digits, so it must have a units and a tens digit. It must be the biggest number that is a prime number. I'm giving you 5 seconds to guess the answer. I think, good, it is 97. 97 is the biggest 2-digit prime number. That might be a question if you have an examination. I think teachers like to ask questions like these because of the fact that learners confuse prime numbers and uneven numbers. But I'm sure from now on you won't be confused with prime numbers and uneven numbers. You have now a way to determine, is this number an uneven number which is also a prime number, or is it just an uneven number? That is for you to decide. And then you must also please go home, please make time to study your rules of divisibility. Then we come to types of fractions. That is what we are actually here for. The rest was just for introduction. Look at the following. We have 3 different types of fractions. We have proper fractions, improper fractions, and mixed numbers. What is a proper fraction? A proper fraction is a number that have obviously a numerator and a denominator. But for proper fractions, the denominator is smaller than the denominator. Like, for example, 1/3 and 5/8. We can say 1/3, but mathematically that won't be correct. So rather teach yourself to say 1/3 instead of 1/3. That is the correct way to speak of fractions. Then we have improper fractions. An improper fraction has got also a numerator and a denominator. For just explanation-wise, it's the top number and the bottom number. The top number again is the numerator and the bottom number is the denominator. For improper fractions, we have a bigger numerator and a smaller denominator. So the top number is greater than the bottom number. The numerator is greater than the denominator. And lastly, we come to mixed numbers. It's like you have those packets of mixed nuts. It's something of they are 2 different things, or more. For mixed nuts, it's more, but if you have mixed numbers, it means there's 2 different things in that number, which is a whole number and also a fraction. If it is a combination of those 2, we call it a mixed number. Like, for example, 3 and 5/7. and 2 and 4 nines. Just for revision, a proper fraction has a smaller numerator than the denominator. An improper fraction has a bigger numerator than a denominator. And a mixed number is a combination of whole numbers and fractions. I'm going to give you 6 numbers and then a few seconds to decide which of these are proper, which of them are improper, and which of them are mixed numbers. Here they come. You have 3/5, 2 and 3/5, and then 5/3, 9/8, 12/13, and 1 and 7/8. All you have to do is write next to each number a P for proper if it's proper, an M for mixed number if it's a mixed number, and an I for improper if you think it is an improper number. Are you ready? So here are the answers. Please check and see if you have them all correct. 3/5 is a proper number because the numerator is less than the denominator. 2 and 3/5 is a mixed number because there's a whole number and a fraction. And then 5/3 is an improper fraction. 9/8 or 9/8 is an improper fraction. 12/13 is a proper fraction because the numerator is less than the denominator. And then 1 and 7/8 is a mixed number. So now that we know about proper and improper and mixed numbers, proper fractions, improper fractions, and mixed numbers, let's see what can we do. Where do we use the knowledge of mixed numbers? How do we do calculations with mixed numbers? If I have a fraction of, let's say it's 1, a mixed number, 1 and 2/3, and I must add 4 and a half. I can do this in 2 ways. I'm going to do it in the way where I change the mixed numbers to improper fractions. Because if I can do this from the start, then it's easier to do the subtraction and also the multiplication. So I want you to teach yourself when you see an improper fraction and you are going to do calculations, then convert the mixed numbers to improper fractions from the start. It just makes it a lot easier when you have to do the other operations as well. How do we convert a mixed number to an improper fraction? I can hear you all saying, oh, you do this and you do this and you do this. Now let's see if you've got your order correct. First of all, I multiply the 3 with the 1. Then I get 3. So I'm going to write it out in full. I'm saying 3 times 1 plus 2. So I plus the numerator. Then I get 3 times 1 plus 2. I cannot leave it like that because it is a fraction. So I must still put in the denominator, which is 3 in this case. I am going to add, what do I do with the 4 and a half? I times the 2 with the 4. Let me write it for you. 2 times 4. What do I do with the 1? I add the 1. I add the 1. And then I also make it a fraction because I have a denominator. If I calculate 3 times 1 plus 2, I will get 5/3. You must check me. Sometimes as mathematics teachers, we make gross mistakes. So please work with me and see that I don't make any mistakes. Then I have an addition sign. 2 times 4 is 8, plus 1 is 9 halves, or 9/2. Now I want to add. Can I add 5 plus 9? And then say the denominator is 3, or is the denominator 2? Wow, what will I do now? I can just imagine that you are giving me some guidance here. I cannot add 5/3 plus 9 halves. Why not? Because the denominators are not the same. So what must I do with the denominators? I must change them. And what is that word again that we use when we change the denominators to the same number? It is the lowest common multiple, the LCM. In mathematics, we like the short way, so we don't say lowest common multiple. It's too long. We use the short versions of LCM. Now, it's important that you know how to convert the denominators to the LCM. What do we do? I'm going to write it here next to underneath the LCM. You write multiples of 3. Do you know what multiples are? Multiples means I must count in threes. So I'm going to count in threes. It's 3, 6, 9, 12, and I can go on and up to infinity. And then I must also count in twos. I'm going to count 2, 4, 6, 8, 10. I almost wrote 9 there. It can also go on up to infinity. Do you see any numbers that is the same, that is common to the multiples of 3, and also a number that is at the multiples of 2? We call that a common factor. The common factor of 2 and 3 is 6. So I will convert my denominator. My new denominator will be 6. What must I do now? I must change these denominators to the new denominator, the lowest common multiple. I must multiply 3 by 2 to have 6. I must multiply 5 by 2. What will I get then? I will have 10. I'm adding. I must multiply 2 by 3 to get 6. I must multiply 9 by 3 to get 27. It's important that you know your times table. You must know your multiples. But that is supposed to be just common knowledge. You just have to know them. There's no way to study them if you are already in grade 7. That is not a waste of time. You should have studied them long ago. But it's never too late, so if you don't know your timetables, please take time to study them and to know them by heart. It should be something that just comes up in your mind without even having to think. You must be able to multiply for the times tables. It must come easy. So what do I have now? I have a 10 and a 27, which I must add, and the denominator is 6. What is 10 plus 27? You are correct. It is 37. And I must divide it by 6. Am I done? Is this my answer? No, it's not my answer. What must I do? I must simplify. With fractions, we must always simplify. It's something you also, when you start with fractions, and you do calculations, you don't even also have to think about that. You simplify your answers. So how do I simplify this answer? I must change what fraction is that? What type of fraction? It's an improper fraction. I must change the improper fraction to a mixed number. And how do I do that? I take the numerator, which is 37. I divide it by the denominator, which is 6. And now, here comes the times tables again. How many times does 6 go into 37? If I can count quickly, you will give me the answer, which is 6. What is 6 times 6? It's 36. So what is my remainder? My remainder is 1. So 37 over 6 is equal to 6 whole numbers, and my remainder is 1 over 6. If I look at this answer and now I want to convert this answer into an improper fraction again, what will I do? I will do what I've started with just to refresh your memory. I have said 3 times 1 plus 2 will give you 5 over 3. And then I said 2 times 4 is 9 plus 1 will give you 9 over 2. This is how we convert from mixed numbers to improper fractions. Now let's reverse the process. If I must change this again into an improper fraction, I must, of course, get this answer, ne? Let's check, see if we can find the correct answer. What is 6 times 6? It's 36. Plus 1 is 37 over 6. So this is how we convert between mixed numbers and improper fractions. And this is also the reason why we must know how to convert. Because if we do a calculation like this and we get to an answer which is not in its simplest form, then we must simplify that answer. In this case, from an improper fraction into a mixed number. Right. Here I have an example for you. It's what I've explained to you now in writing. I have a mixed number 2 and 4/9. I want to convert the mixed number into an improper fraction. Then I must say the denominator times 2 plus 4 is equal to 22 over 9. I will also, for the next one, I will say 13 times 7. What is 13 times 7? We had it on the previous workout. 13 times 7 is 91. Is 91 again a prime number? No, it's not a prime number because 13 and 7 are also fractions, factors of 91. Then I plus 6 and I get 96 over 13. On the next slide, I have some examples for you to do. Just look at them for a few seconds. You can pause your screen and then you can see if you can calculate them as we go along. I will just do the explanations, but when you are at home, please take time to do these conversions from mixed numbers into improper fractions by yourself so that you are sure. And then you can look at the calculations that I've shown on the screen again. You can unpause your video and then you can see if you have done them correctly. The first one is 3. 3 1/4. If we must convert this to an improper fraction, what do? We say 4. Let me just change the screens. We say 4 times 3 is 12, plus 1 is 13 over 4, or 13 quarters. Then we have changed to an improper fraction. The next one will be 2 and 5 over 48. There you have it. Wow, this is a big denominator. I think if you do that mentally, what is 48 times 2? Who can tell me? Quickly guess. Quickly work out. 48 times 2 is 96. It's 96 plus 5 will give you 5 plus 6 is 11. And then I carry the 1, it will be 101. And don't forget, it is still a fraction. It is still 48. So it will be 101 over 48. Right, that is the answer of the second one. For the third one, we have, sorry about that, we have 12 and 7/11. What do? How do I convert this to an improper fraction? I multiply. What is 11 times 12? Welcome back, everybody. We have taken a pause to give you time to calculate these improper fractions, to convert them, the mixed numbers into improper fractions. What I have on my screen is 3 1/4, which is a mixed number, 2 and 5/48, which is also a mixed number, and 12 and 7/11, which is also a mixed number. I hope you have had time to convert them into improper fractions, and this is how we will do them. If I start with 3 1/4, I said, or we decided, we must multiply the 4 with the 3 to give you 12, plus the 1 will give you 13 quarters. Next one is 45 times 2. I think I had 46 on the question, but let's do 45 anyway. What is 45 times 2 will give you 90, and 90 plus 5 will give you 95 over 45, which is then an improper fraction. If I have 11 times 12, 11 times 12 is 132. Plus 7 will give you 139 elevenths. I just want to go back to get the correct one so that I can give you the corrections for that one. It's 2 and 5 48ths. I do the same with this. I will say 48 times 2 will give me 96 plus 5. 48 times 2 will give me 96, plus the 5 will give me 101. Am I correct there? I think I'm missing something. Can you see what I'm missing? I am missing the denominator, which is 48. My denominator is always there. It must be 48. Don't just write the numerator numbers. You must remember to write the denominator as well, because we are working with fractions. Now we can continue. You will remember that I've explained to you how to find the LCM. What is the LCM again? It's the lowest common multiple. That is the key word. I work with multiples. Multiples of 3, multiples of 5, which means I count in 5s or I count in 3s. Those are multiples of a number. And if I want to find the lowest common multiple of, for example, 2 or 3 or 4 or 5 numbers, I find the multiple that is common for all 3 or 4 or 5 numbers. That is the common multiple. Another abbreviation that we have is the HCF. I spoke about the HCF earlier. I also said you can say it is the GCF. The HCF is the highest common factor. When we simplify fractions, we can convert between mixed numbers and improper fractions. We simplify an improper fraction and then we make it into a mixed number. But what if the fraction is not a mixed number, but you still have to simplify? Let's consider the following fraction. Let's say it's 52 over 130. My numerator is 52. My denominator is 130. I can see they are both even numbers, so I can divide by 2. I will divide by 2 and maybe I will have to divide again and again until I can divide no more. What is important here is that you must divide. The teachers say, what you do at the top, you must do at the bottom. And I also say that because I'm a teacher. What you do at the top, you must do at the bottom. So I can find the highest common factor between 52 and 130. And how do I do that? I can make like a line sum. We call that a line sum, just for the learners to remember. I can see that it is an even number, so I can divide it by 2. The numbers on the left side of the line should only be prime numbers. So I'm going to keep on dividing until I can divide no more. Remember, all these numbers must be prime numbers. 2 divided into 5, 2 times, remainder 1. 2 divided into 12 is 6. Oh, it's another even number, so I can divide. 2 divided into 2 is 1. 2 divided into 6 is 3. Correct. Or can I divide anything into 13? Apart from 13, of course, yes, I can divide 13 only by 13, which means in this case that 13 is a prime number. 13 divided by 13 will give you 1. So the prime numbers, the prime factors in this case of 52 is equal to 2 times 2 times 13. As you can see there, it's 2 times 2 times 13. And 2 times 2 times 13 will give me 52. Let's see what we can do with 130. It's also an even number. I can divide by 2. Is 2 a prime number? Yes, 2 is a prime number. 2 divided into 1 is, it cannot, it's too small. 2 divided into 13 is 6, correct. And I have a remainder 1. 2 divided into 10 is 5. Is 65 a prime number? Can it still be divided? Is it even? Is it uneven? The rule for divisibility says if the unit digit is a 5, then I can divide the number by 5. So I see it's not a prime number yet. I'm going to divide 65 by 5. 5 goes into 6 one time, remainder 1. Then 15 divided by 5 will give me 3. And I'm sure you see the connection now. There is a 13 and there is a 13. So maybe there will be a highest common factor. I can divide by 13. 13 divided into 13 is 1. So that I just end with 1. Then I know there's nothing more that I can divide into or divide with. So the prime factors of 130 is I have 2 times 5 times 13. There is my 13. Can you see which numbers or which factors, which prime factors are common? I have for 52, this is a prime factor. I have for 132 as well. 2 and 2 is a common factor. And then 13 is also a common factor. So the highest common factor, which means the biggest number that I can divide both into 52 and also into 130 will be 2 times 13, which is 26. Now, if I go back to my fraction there at the top, I have calculated, I have seen that the prime number, the highest common factor of 52 and 130 is 26. Now I can do, as I said, what you do at the top, you do at the bottom. I divide 52 by 26 and I divide 130 by 26. How many times can 26 be divided into 52? I have my answer already. It is 2 times. I've already calculated that. So my new numerator, my simplified numerator will be 2. How many times can 130 be divided by 26? I know you can see the answer because we've already done this. It is 5 times. I've already calculated the prime number and even the answer of that. Then it will become 5. So if I simplified 52 over 130, my simplified fraction will be 2/5. I will just give you a moment to see what I've done here again. See if you understand my method, and maybe you have a different method of calculating the prime factors. There are different methods. This is the one that I am easy with, and I enjoy doing this because it feels I like things that are in a straight line, and this one is in a straight line. Okay, if you feel safe about this, I think we can continue. Now, what do we do? What can we do with all these simplifications and calculations that we have already done? We can use mixed numbers, and we can use proper and improper fractions when we plus, minus, times, and division, and divide with fractions. So fractions is not just how to write a fraction, it's also how to do calculations with fractions. The example that I have there in front of you is an addition sum. You can see there that I have 2 1/4 plus 1 2/3. What kind of fractions or numbers are those? They are mixed numbers. So as I said before, now we convert the mixed numbers to improper fractions. You will see that I have said 4 times 2 plus 1 gives me a new numerator of 9. And my denominator is still 4. Plus, if I convert 1 2/3 to an improper fraction, I will say 3 times 1 plus 2 will give me 5/3. It's important that you write the denominator. You just carry the denominator with you all the time because we are working with fractions. You will see there the letters in red is the lowest common multiple. I have explained to you how to find the lowest common multiple between 4 and 3. You find multiples of 4, you write them down. Let me show you again just for reminding you. I have multiples of 4 is 4, 8, 12, 16 and on. I can count, as I said, into infinity. Then I have 3, 6, 9, 12, 15 and on. Which multiple do you see for 4 and also for 3? Yes, there it is. It is 12. This is the lowest common multiple of 3 and 4. So my lowest common multiple of 3 and 4 is 12. I've already changed it for you. You will also see I'm stressing again. What I do at the top, I must do at the bottom. 9 times 3 is 27. 5 times 4 is 20. My denominator is 4 times 3, 12, and 3 times 4, 12. Now my next step will be to add the numerators. Remember, the numerators are the number at the top. If I have 20 plus 27 will give me 47 twelfths, 47 twelfths. And now the red light comes on because it is not in its simplest form. What do I do if I have, what kind of fraction is that again? It is an improper fraction. Improper fraction I must convert to a mixed number. How do I convert an improper fraction to a mixed number? I divide the numerator by the denominator. And I've written to you there, it's 47 divided by 12. If I count in 12s, it's 12, 24, 36, 48. Or it can't be 4 times, no. So I can only divide 12 3 times into 47. And then I will be left with 11. What do I do with my remainder? I write it as a fraction. You can see the answer there is 3 and 11 twelfths. Right, just a few seconds to check again if you understand what I've been saying. Learners, you will have to do this. You will have to take time to practice fractions and the calculations that we do with fractions. It comes easy if you are sure what to do. But remember, now we do fractions and then time goes by, you do exponents and all the other topics, and then in the test or in the exam or when you come to grade 10 and 11 and 12, what do you see? I see fractions. Then you must still know. These things must be imprinted in your mind. You must know how to do fractions. So rather practice these now and see as time goes by that you remember. Check yourself regularly so that you know you are still up to par. That was an addition sum with mixed numbers. So what do we do if we have a multiplication sum with mixed numbers? You do the same. You start in the same way. You convert a mixed number to an improper fraction. That is important when you do calculations with fractions. I have done there for you 5 times 1 plus 7 will give you 12 fifths. And then I have on the other side, the second fraction is 2 and 1/3. The mixed number I convert to an improper fraction. 3 times 2 plus 1 is 7/3. You can see there's something new. There's something new that says solution. I have 12 fifths times 7/3. And then you will see some funny lines being drawn through the numbers. Why do they do that? It's a simple way of simplification or dividing, making the number smaller before I get my final answer. You can do this also in 2 ways. I'm going to explain to you. I have 12 fifths times 7/3. I can see that there is a common factor between 12 and 3. Oh, maybe I can divide. So I draw a line. I see the common factor is 3. Can 12 be divided by 3? Let's count. 3, 6, 9, 12. Yes, 3 divided into 12 is 4. And 3 divided by 3 is 1. It's a way of making the number smaller so that you don't have to simplify such big numbers when you come to your final answer. So let me finish this one first, and then I will show you the other way, the longer way. But it's your choice. Whichever one you understand best is the one that you will do. Now I have 4 times 7, which gives me 28. And I have 5 times 1, which will give me 5. Let's just leave it at that for the moment, and then let me show you the other method. The longer method, but maybe for some the easier method. If I have 12 fifths times 7 thirds, instead of dividing by 4 or by 3 or a number that is common, a factor that is common, I can multiply the top numbers, which are the numerators, with the bottom numbers, which are the denominators. So I will have 12 times 7, quick, is 84. And 5 times 3 is 15. Now I have an improper fraction here. I have an improper fraction there. And then what must I do? I must convert it into a mixed number. Let's see how many times can 5 be divided into 28. Correct? It is 5 times, because 5 times 5 is 25. My remainder will be 3, and it's not a 3 just hanging there in the air. It is a 3 over 5, which will give me 3 fifths. On the other side, I have 84. Do you think these answers are the same? Let's see if we get the same answer for both of these sums. Now, if my calculations were correct, we ought to get the same number. You can check me now. I have, how many times does 15 go into 84? You can do it the long way, or you can just know it. I'm going to do it in the long way. So it's 15, if I count in multiples of 15. It's 30, and then 45, and then 60, and then 75. I'm showing you this to show you that you don't have to know everything by heart. There are ways to calculate to help you ensure that your answers are correct. Don't just jump all the steps if you are not sure how to do a calculation. So how many times did I count in 15? It's 1, 2, 3, 4, 5 times, which means that 15 can be divided into 48 5 times. How many do we have left? So we say 84 minus 75, which will give me, quick calculation from your side. What is 14 minus 5 will give you 9 over 15. See why I said this is the long way? Now I still have to simplify this fraction because it's not in its simplest form. A common multiple between 9 and 15 is 3. I can divide by 3, which will give me 5 and 3 fifths. Yippee, I can see. I have done my calculations correct. The two answers are the same. This is another way. This is the short way. It doesn't matter which way you use. Any one that is easy for you or that you understand is the way that you will use. Let's see if we can do some practice. Practice numbers, practice calculations for you. I'm going to ask you to pause your screen and then see if you can do these calculations on your own. I am just going to do the first one. Let's start with the first one. I have 2 and 3/8 minus 1 and 5 sixths. Step number 1. Now you must work with me. Step number 1 said we must convert the mixed numbers into improper fractions. These are mixed numbers, as you can see, because we are doing mixed numbers to improper fractions today. What do? I say 8 times 2 will give you 16, plus 3 will be 19 eighths. And I have 6 times 1 is 6, plus 5 is 11 sixths, minus step number 2. You must check your steps now. What must we do now? We must find the LCM of 8 and 6. What is the LCM of 8 and 6? I'm going to count in eighths. It's 8, 16, 24, and then 30 and on. And if I count in multiples of 6, it's 6, 12, 18, 24, 30, and on. You will see here are two common multiples. It is 30, which is a common multiple, and 24. Sorry, that is a mistake. That must be 32. Whoa. Sorry, mathematicians. That was a gross mistake that I made on my part. So there's only up to now one common multiple, which is 24. Fortunately for me, I realized my mistake. So my new denominator will be 24. If I write it like this, I can see they will both be over the same denominator. 8 times 1, 2, 3, 4 will give me, no, only 3. 8 times 3 will give me 24. What is 19 times 3? Can you do that mentally? It will be 3 times 9 is 27. 3 times 1 plus 2 is 5. Good, it's 57 over 24. 6 I must multiply 1, 2, 3, 4 times. 6 times 4 will give me 24. 11 times 4 will give me 44. And I'm still subtracting here. My new denominator is 24, and now I can calculate 57 minus 44, which will give me 7 minus 4 is 3, and 5 minus 4 is 1. 13 over 24. And now we have to decide, is this fraction in its simplest form? Can 13 be divided by a common multiple of 24? Anything that I can divide these numbers by? No. I think we are done with this problem. So on the screen you will see 4 different problems. For other problems, I want you to take your time, do them at home, and then take them to your teacher. Ask him or her to check for you. If you have understood how to do calculations with mixed numbers and how to convert from mixed numbers to improper fractions, how to simplify, here they are for you. Number 2 and 3 and 4 and 5 you can do on your own at home, and please ask your teacher to check you. If you can do these 4 calculations, these 4 problems, then it is safe to assume that you now understand how to do calculations. But as I said, it's not safe to assume that you will always remember. In mathematics, the word we use is practice, practice, practice. If you love mathematics, if you want to be good at it, if you even just want to be sure of what you understand or not, then you have to practice. And there are lots and lots of material for you, extra material. Take time and study mathematics, and please cultivate a love for mathematics. It always makes it easier to do something if you like something. I thank you, and I hope you have a good day.